Saturn's north pole has a storm shaped like a perfect hexagon. Each of its 6 sides is longer than Earth's diameter. The entire structure measures 29,000 kilometers across. Nearly 4 Earths could fit inside it side by side. Storms on Earth tear themselves apart in days. Hurricanes wobble, distort, collapse. They are chaos given form. But this hexagon has held its shape since at least 1981. 40 years of observation, and every photograph shows the same 6 sides, the same angles, the same geometric precision. A storm the size of a planet, shaped like something drawn with a ruler, and it refuses to change. Scientists expected storms to be round. Every hurricane on Earth is round. Every cyclone on Jupiter appeared round. Fluid dynamics said rotating systems should produce circular symmetry. Angular momentum pulls everything into curves. Then Voyager 1 and Voyager 2 flew past Saturn in 1980 and 1981, capturing thousands of images of the planet's atmosphere. The data sat in archives for years. In 1988, David Godfrey at NOAA began processing the old Voyager frames, enhancing contrast, stacking images. What emerged was impossible. A 6-sided polygon sitting directly over Saturn's north pole, perfectly centered, perfectly stable. Here's something almost nobody mentions. When Cassini arrived at Saturn in 2004, scientists couldn't even see the hexagon. Saturn's north pole was tilted away from the sun, locked in winter darkness. They had to wait 5 years until 2009 when sunlight finally returned to the northern hemisphere. And there it was, unchanged. Same 6 sides, same position, same size. 28 years between Voyager and that first Cassini sunlit image, and the geometry hadn't shifted at all. Think of it like a cup of coffee. Spin the cup fast enough and the surface doesn't stay round, it develops corners. Oxford researcher Ana Claudia Barbosa Aguirre proved this in 2010 by spinning fluid in a tank and producing hexagonal patterns. Saturn's atmosphere does this naturally at planetary scale. But here's what made the 2018 observation strange. The hexagon extends upward too. The hexagon forms through something called a Rossby wave, a meandering pattern that develops when a fast-moving jet stream interacts with slower surrounding air. On Earth, the polar jet stream meanders too, creating the wavy weather patterns that push cold air south in winter. But Earth's jet stream is chaos. Continents heat unevenly. Mountains deflect airflow. Oceans absorb and release energy unpredictably. Saturn has no solid surface. No continents, no mountains, no coastlines disrupting the flow. The jet stream circling Saturn's north pole moves at approximately 320 kilometers per hour, faster than any Category 5 hurricane on Earth. That specific velocity, interacting with Saturn's rotation period of 10 hours 39 minutes, creates a resonant condition. The wave pattern locks into exactly 6 peaks. If you drove a car at highway speed along one edge of the hexagon, the trip would take over 48 hours non-stop. 6 sides, each one longer than Earth's diameter. The central eye alone spans 2,000 kilometers, roughly the distance from Los Angeles to Chicago, with clouds descending 100 kilometers into Saturn's atmosphere. Jupiter's south pole has a stable pentagon of cyclones. Neptune's poles show vortex structures. Laboratory tanks produce triangles, squares, pentagons, hexagons, heptagons, octagons, all depending on rotation speed. Saturn's hexagon isn't violating physics. It's demonstrating physics at a scale we can actually observe. By the way, the hexagon changes color. Cassini's final observations in 2018 showed a separate high-altitude vortex forming above the main structure, shifting hues with the seasons. And that color change reveals something about Saturn's interior that nobody expected. The hexagon's persistence proves something about Saturn's guts. For a wave pattern to maintain perfect geometry for 4 decades, the atmospheric layers below it must be extraordinarily stable. Minimal convective disruption, minimal turbulence rising from the interior. This constrains every model of Saturn's internal heat distribution. The planet radiates more energy than it receives from the sun. Something is generating heat deep inside. But that heat isn't churning up through the atmosphere chaotically. It's moving in ways that preserve the delicate wave dynamics at the surface. Earth's atmosphere resets constantly. Whether systems live for days, maybe weeks. The hexagon has outlasted every storm ever recorded on our planet. It was spinning when Reagan was president. It's still spinning now. Actually, there's something worth noting about what sits inside the hexagon. The central vortex eye, that 2,000-kilometer-wide pit in the clouds, has wind screaming around its edges, but the eye itself is relatively calm. Cassini measured clouds dropping 100 kilometers below the surrounding deck. That's deeper than Earth's entire atmosphere is tall. The hexagon provides something no Earth-based laboratory can: a clean test case. Rossby waves drive weather patterns on Earth, Jupiter, and potentially on exoplanets we're only beginning to characterize. But every terrestrial example is contaminated by surface effects. Saturn's hexagon is pure fluid dynamics, running continuously. With geometry we can measure precisely from 1 billion kilometers away. And right now, the most powerful telescopes ever built are measuring it. The James Webb Space Telescope observed Saturn in June 2023 using its NIRCam and MIRI instruments. The infrared images reveal temperature variations and chemical composition within the hexagon at resolution no previous telescope could achieve. Webb can see heat. It can map where the atmosphere is warmer, where it's colder, where different molecules concentrate. The hexagon is no longer just a shape. It's a three-dimensional thermal structure being dissected layer by layer. Hubble continues annual monitoring through its Opal program. The Outer Planet Atmosphere's Legacy survey tracks storms across all 4 giant planets year after year. Ground-based observatories, including Keck and the Very Large Telescope, are watching seasonal changes as Saturn's North Pole tilts toward maximum sunlight in 2032. That's the next major milestone. Maximum solar illumination of the hexagon. Every instrument will be pointed at Saturn when it happens. Here's something most people don't realize. Cassini's final observations revealed the hexagon extends at least 300 kilometers above the main cloud deck. There's vertical structure nobody predicted. The high-altitude vortex that changes color seasonally. That's not the same system as the hexagon below it. They're stacked. Whatever process maintains the hexagon's shape is operating across hundreds of kilometers of vertical atmosphere. If the Webb data matches Cassini's measurements, the hexagon has been stable for over 40 years at multiple altitudes. If the measurements diverge, something is changing. And what started as a geometric curiosity in old Voyager data becomes a window into how planets work. Saturn's North Pole has a storm shaped like a perfect hexagon. Each of its 6 sides is longer than Earth's diameter. The entire structure measures 29,000 kilometers across, and it has held that shape since at least 1981. Now you know why. A jet stream moving at precisely 320 kilometers per hour. A rotation period of 10 hours 39 minutes. No solid surface to break the symmetry. The mathematics demanded 6 sides and Saturn obliged. 40 years and counting. A geometry class written in clouds, running at planetary scale, waiting for anyone with a telescope to see it. How many years do you think the hexagon will last? Another century, or longer than human civilization? Follow Pancake's house, new video every week.